Well, good afternoon, and I'm delighted to be able to talk to you about work we've been doing at the University of Oxford and many other places around the world on quantifying how methane emissions in particular impact our global climate. Let's phrase this as a challenge and an opportunity and an obstacle which we also need to face. First of all, methane emissions are a big deal. I cannot emphasize this enough. Global methane emissions are going up. It's the second most important driver of global warming after carbon dioxide. And right now, methane emissions are responsible for perhaps almost half the warming caused by carbon dioxide. So it's a big driver of global climate change. We have to turn that around. And we need farmers' help to do that, livestock farmers in particular, because livestock does contribute to global methane emissions. The obstacle we face is that the current way we measure the impact of methane on climate simply isn't fit for purpose. We use this rather simplistic notion of treating methane as a carbon dioxide equivalent gas and argue interminably about how many tons of methane, how many tons of carbon dioxide is a ton of methane is worth. And I will try and explain to you how that whole notion of equivalence simply doesn't work. But fixing this problem, and it's a relatively simple technical accounting problem that could be fixed, actually generates us an opportunity because it makes clear how we can refocus climate policy onto warming outcomes, which would actually help everyone, particularly the livestock sector, to engage with climate policy in a positive way, helping to deliver our climate goals rather than in a rather defensive mode of feeling threatened by climate policy overall. Fixing this problem, this simple accounting problem, would make it much easier to engage agriculture in effective climate policy. Let me give you some simple data to show you the scale of the problem we're facing. On the left is the UK's total emissions in the conventional carbon footprinting approach since 1850, expressed using the standard carbon dioxide equivalent measure. And you'll see the red line there shows that our emissions as a nation are dominated by carbon dioxide, although we've had substantial contributions from methane as well. And both carbon dioxide and methane emissions have been going down since around the 1980s or so. Now, on the right, we see the contribution of UK agriculture to those emissions. And the balance of different gases is very different for agriculture. Agriculture's emissions are dominated by methane, most of those coming from the livestock sector, with a substantial contribution also from nitrous oxide in green and relatively little from carbon dioxide. This is why these issues with how we measure the impact of methane on climate are particularly important for agriculture and for the livestock sector in particular. I cannot emphasize enough, methane and carbon dioxide are not actually equivalent. These little schematics show you what the different impacts are of carbon dioxide and methane on global temperatures. On the left, we have the impact of rising emissions. If carbon dioxide emissions and methane emissions are rising, they both cause warming. Rising carbon dioxide emissions, in fact, cause warming that steadily accelerates, whereas rising methane emissions causes warming in pretty much a straight line, but you wouldn't really tell the difference over recent decades. Both carbon dioxide and methane have been causing very substantial amounts of global warming because emissions have been rising, and we have to turn that around. When we look at constant emissions of methane and carbon dioxide, and it's worth stressing that in the UK, both methane emissions and carbon dioxide emissions leveled off in the sort of latter part of the 20th century. And the impact of constant emissions of carbon dioxide and methane are very different. They both cause warming, but methane, crucially, causes much less warming than notionally equivalent emissions of carbon dioxide using the conventional carbon dioxide equivalence measure that everybody like DEFRA or the UK government, other parts of the UK government always use. Finally, the contrast between them is even more stark when we look at the consequences of falling emissions. Falling carbon dioxide emissions cause warming to slow down. That's because carbon dioxide is what we call a cumulative pollutant. It accumulates in the climate system, like lead in the bloodstream. The only way to stop carbon dioxide from causing global warming is to stop emitting carbon dioxide altogether. That's why we're aiming for net zero carbon dioxide emissions by mid-century. Falling methane emissions have a very different impact. Methane is not a cumulative pollutant. It's what we call a short-lived climate pollutant. It has a lifetime of only about 10 years in the atmosphere. So as soon as methane emissions start to fall, the amount of methane in the atmosphere follows them down and temperatures follow along. So falling methane emissions have the same impact on global climate as active removal of carbon dioxide from the atmosphere. For example, you could plant a tree, take carbon dioxide out of the atmosphere, and that would act to cool global temperatures. Or you could reduce your herd size or use feed additives to reduce your herd's methane emissions. That would have the same impact, but it would be treated very, very differently by our current accounting systems for greenhouse gases. I'd like to stress this science is very well established indeed. There was a statement in the most recent assessment of the Intergovernmental Panel on Climate Change expressing methane emissions as CO2 equivalent emissions using the 100-year global warming potential. That's the standard unit of account that everybody uses to convert methane to carbon dioxide, overstates the effect of constant methane emissions on global temperature by a factor of 3 to 4, while understating the effect of any new methane emission source by a factor of 4 to 5 over the 20 years following the introduction of the new source. Now, that sentence you probably have to read that sentence a couple of times to really get the hang of it, but in the end, it's pretty simple. The point is, if you're responsible for a constant source of methane, then treating your methane as CO2 equivalent exaggerates your impact on global temperature. While if you're responsible for a new source of methane or have started a new source of methane at some point in the past 20 years, then the conventional accounting system will understate your impact on global temperature. And these things are all explained in, if you want to follow up, and you can follow up that link and look at John Lynch's article, which gives a nice overview of this. So, I've been criticizing the standard way of accounting for it. What do you have to do if you actually want to work out the actual impact of methane emissions from your farm on global temperature? So just to remind you, the standard CO2 equivalent, the standard carbon footprinting calculation that's used by the BBC's footprint calculator, food footprint calculator, and all these things which you can sort of see readily online. All they do is they multiply each year's methane emissions by a factor of 28 to say that's the equivalent carbon dioxide emissions. And that, as I keep stressing, basically gives you the wrong answer. If you want to know the actual impact of your methane emissions on global temperature, what you need to do is multiply last year's methane emissions by a factor of 128, so a much bigger number than 28, but then you need to subtract your estimated methane emissions from 20 years ago multiplied by 120. So I've given you the formula there. You can mull it over. It's not very complicated. The old formula involves one multiplication. The new formula involves a multiplication and a subtraction. Many people say, oh, this is far too complicated. We couldn't possibly change the system. Nobody will ever understand it. Yeah, I think people can understand this. It's really not very complicated. So your warming impact over the past 20 years is proportional to aggregate, just add them up, carbon dioxide and nitrous oxide emissions expressed as CO2 equivalent, because nitrous oxide, by the way, behaves very like CO2. It's a cumulative pollutant as well. So we can just add up CO2 and nitrous oxide emissions, but then you have to add on your warming equivalent methane emissions, calculated using the formula, the second formula I'm showing you on this slide. So you can do this. You can work out the impact of your farm on global temperature. And if you do, you'll find that if your emissions have been unchanged over the past 20 years or longer, then you only need to multiply them by a factor of 8, 128 minus 120. So your conventional carbon footprint, which involves multiplying your methane emissions by a factor of 28, would be 3.5 times too high. Hence the Intergovernmental Panel on Climate Change's statement that the conventional carbon footprint calculation overstates the impact of a constant methane source by a factor of 3 to 4. So you see, it's all making sense. If your emissions have risen in the past 20 years, then you have to multiply those new emissions by 128, because any increase in methane emissions causes lots of warming. As I said right back at the outset, it's very important to recognize that rising methane emissions cause very substantial global warming. We cannot afford to increase methane emissions globally or nationally. If, on the other hand, your methane emissions have fallen by 6% over the past 20 years, okay, you realize where the 6% comes from, that's 8 over 120, or 0.3% per year, then if you just apply that formula, you'll realize that your warming equivalent emissions of methane are net zero. Your farm's methane emissions are not causing any further global warming. You might have caused global warming in the past when you built up your herd, but if your emissions are declining by 0.3% per year, they are no longer adding to the increase in global temperatures. And of course, if your emissions are falling faster than 6% over 20 years or 0.3% per year, then your farm, those emissions are having the same impact on global temperature as actively removing carbon dioxide from the atmosphere, the negative warming equivalent emissions. Let me show you what this means in actual numbers. Back to that picture of UK emissions since 1850 and the contribution on the right from UK agriculture. If we calculate the impact of these emissions on global temperature, we see on the left the UK's total contribution to global warming, dominated by carbon dioxide, and on the right, agriculture's contribution to warming, dominated by methane. But notice, while UK agriculture drove up global temperatures up to around 2000 or so, right now, that solid blue line has started to go down. The impact of UK agriculture on global warming has pretty much leveled off. UK agriculture is no longer contributing to an increase in global temperatures. And that's been achieved largely because of falling methane emissions from the ruminant sector over the past 20 to 30 years. Now, if we look at over on the right there, you'll notice that the dashed line, which is just treating methane as carbon dioxide equivalent using the conventional carbon footprint measure, suggests that methane emissions from UK agriculture is still causing warming, but it's not. As I've explained, once methane emissions start to fall, that conventional measure of carbon dioxide equivalent emissions becomes very misleading. It just gives you the wrong answer altogether. If we focus on warming since 1990, then on the left, it's the UK's total contributions to warming, solid lines here, and on the right, it's agriculture's contribution to warming. You can see that the solid black line has leveled off since around 2005. UK agriculture is no longer contributing to increasing global temperatures. That said, it would be possible to do even more. The dotted lines show you that if we had just purely hypothetically shut down UK agriculture entirely in the year 2000, I should stress this is a complete sort of thought experiment, we would have actually caused some global cooling. We'd have reduced global temperatures. Of course, that would only have had that effect if the UK population had also stopped eating, because it doesn't work if you shut down your own agricultural sector and then just import the same food from abroad. So, okay, so it's a entirely hypothetical exercise, of course, but it's to illustrate there is scope to deliver more than just no longer causing global warming. It would be possible for UK agriculture to actually help compensate for the warming caused by other sectors. But if the UK agricultural sector does that kind of favor for other sectors, then you could argue you should be compensated for doing so. So this is really the nub of what I'm arguing that you, as ruminant farmers, should be arguing for. We need collectively to frame climate policy in terms of warming outcomes rather than emissions inputs. At the moment, the climate impact of a farm or of a stake is measured in terms of its nominal carbon footprint. And as I've tried to explain to you, this bears very little relation to its actual impact on global temperature. And this causes problems. It's inefficient because it fails to give people the right incentives to reduce their impact on global temperature, and it's arguably not fair. For example, a crop farmer who converts to forestry and thereby takes carbon dioxide out of the atmosphere by growing trees, under the sort of the environmental land management systems that people are talking about introducing under the Environment Act, that farmer would be rewarded for taking carbon dioxide out of the atmosphere, because they would be thereby reducing global temperatures. Under the conventional accounting system, a livestock farmer who reduced their herd's methane emissions, either through feed additives, vaccines, or perhaps by reducing the herd size, they would be having exactly the same impact on global temperature as the crop farmer who's planting trees, but they would simply be penalized less for reducing their overall carbon footprint. That doesn't make sense to me. If both farms are having exactly the same impact on global temperature, they should be rewarded appropriately. In pursuit of a temperature goal, and that's what we are aiming for to limit our impact on global temperature. That's the ultimate goal of the Paris Agreement on climate change. We need to penalize actions that increase global temperature, reward actions that reduce them, and we also need to ensure that any reductions are permanent. So what can we do about this? Well, leaving the Common Agricultural Policy has provided the UK with an opportunity for policy innovation in this space. And it's an opportunity we need to seize, but it's an opportunity that's kind of slipping away at the moment because there is considerable inertia behind the traditional way of measuring carbon footprints. Every supermarket in the country, every civil servant in DEFRA are just completely used to this old way of accounting of treating methane as carbon dioxide equivalent. And it's going to take a concerted effort from the sector that's most affected by this problem, the livestock farming sector, of course, to turn this thing around. I've met some very sympathetic politicians. Faye Jones, for example, MP, is well wised up to this particular challenge. But they're few and far between. This is not a priority for most urban politicians because in the big picture, the UK emissions are dominated by carbon dioxide. We've reduced our methane emissions quite substantially already, mostly by taxing landfill, by the way. And so methane's just not really a big, getting methane right doesn't seem to be that much of a policy priority. for the UK government. But it does make, and it will make, a huge difference to the impact of climate policy on your sector. You should be arguing for being rewarded for your impact on global temperature, and also accept that the converse is also fair, that you should be penalized for adverse impacts on global temperature, driving up global temperature. So we should absolutely not allow herd sizes to increase, because that would have a very negative impact on global temperature, unless, of course, we can get methane emissions under control through other measures. But if we continue with the recent trends of stable or gently declining herd size, ruminant farmers deserve to be rewarded for the favor they're doing to other sectors by compensating for the warming that those other sectors are causing through their carbon dioxide emissions. I've stressed this is an uphill struggle. We've been arguing for this innovation. It's a relatively simple policy innovation. Measure warming impact, don't measure carbon footprint. You'd have thought that would be an easy sell. It proves very, very hard to sell. There's considerable inertia behind the traditional accounting system. But what you could be arguing for, and I think this is a realistic win, would be to require everyone, particularly including DEFRA, to start to report warming impact as well as carbon dioxide equivalent emissions using the traditional metrics. You'll find if you talk to a politician or civil servant about this, they'll say, well, the UK Climate Change Act of 2008 was written in terms of 100-year global warming potentials. Our international commitments are in terms of 100-year global warming potentials. That's the system. Live with it. We're not going to change anything. Fine. Go with that. Continue to report the conventional way. But as well as that, report your actual impact on global temperature through your warming equivalent emissions. I find it hard to believe that anybody could seriously object to knowing what the impact of your farm is having on global temperature when we're trying to stop global warming. If they do object, you've always got the comeback line, well, it's global warming, stupid, so to speak. That's what we're trying to do. We're trying to stop global warming. We should align incentives with impact on global temperature. And at the very least, we should report impact on global temperature as part of the standard environmental reporting measures being introduced following our exit from the Common Agricultural Policy. But it's going to take a lot of work from you. And I apologize if this talk has been a lot of work for you to digest, but there's a lot at stake here. Thank you.